Ja, hej och välkomna allihopa. Mitt namn är Mattias Ehrenborg och jag är analytiker på ABG. Jag bevakar en knippe småbolag med bland annat, främst med fokus på industri och förnyelsebar energi. Och idag så har jag äran att presentera Sintercast och dess vd Steve Dawson här. Och den här presentationen kommer tas på engelska då, eftersom att du är engelsktalande. Och jag ska inte stjäla mer tid helt enkelt, så the floor is yours.
Good, Matthias, thank you. Good morning. So I think that most of us are familiar with Sintercast, so I'd just like to start with a small introduction to a company, and then let's jump straight into the market. We'll see the current market activities and the outlook, and what I'd like to do today is to spend a little bit more time introducing a new technology that we've been developing. So Sintercast has specialized in the process control for the production of a new type of cast iron called compacted graphite iron, or CGI. Traditionally, there were two types of cast iron. One that was very good at transferring heat and dampening vibrations, but it was rather weak and brittle. And another type of cast iron that was very strong and stiff, but it wasn't good at transferring heat, and it's difficult to cast. So if we try to make a complex shape, it will have defects like porosity. CGI as a cast iron is in between those two materials, and so it's ideally suited when we have both the thermal load, like in engines, and also a mechanical load. So our main application for the material is automotive, and specifically cylinder blocks and heads, and things like turbocharger housings and exhaust manifolds, right? Things that have both mechanical and thermal load. Sintercast is the industry leader for the provision of process control technology for CGI. We don't actually make the castings, so we provide our technology to the foundries, and they in turn produce the castings and deliver them to the end users, the OEMs, either for car or truck applications. We started here in the home market of Sweden and in Europe, and as the business grew, we expanded into Asia. We now have an office in Beijing and an office in Korea. We have an office in the Chicago area of the United States, and most recently we've taken on a full-time position in Latin America, based in Sao Paulo, to support the Latin American market. Over the years, our production has developed. The first series production of CGI was a 3.3-liter V8 engine for Audi in 1999. From that time, we now have 75 different components in production. They're produced in 22 different foundries in 11 countries around the world. And if the first engine block was made in 1999, this year our technology will be used for the production of more than 1 million cylinder blocks. So, of course, we would have liked it to be bigger and faster, but it's a really good growth, and it's a really good success story. That introduces our core market, which is the compacted graphite iron process control. And later in the presentation, I'd like to introduce our tracking technologies, which have been developed to improve the process efficiency and the traceability in the foundry industry. In production today, if we start with the passenger vehicle sector, we're producing more than 75,000 cylinder blocks per month. It's for companies like Audi, Fiat Chrysler, Ford, Hyundai, Kia, Nissan, and Volkswagen. And today, you can buy a Sintercast CGI engine in 61 different vehicles. Yeah, so it's really become a mainstream technology. I mentioned earlier that we also do turbocharger housings and exhaust manifolds. Those are all delivered to Honeywell and Borg-Warner, who in turn build the assemblies and deliver them to different OEMs. The biggest OEMs for those production is BMW, Renault, and Volkswagen. In the commercial vehicle sector, we make both cylinder blocks and cylinder heads. So here in this picture in the middle, you can see for a 12-liter engine, the cylinder block and the head. 22 different components in production for companies like DAF. For Ford, we do 7.3 and 9-liter engine. For Hyundai, we do both cylinder blocks and heads. Jiangling Motors in China, we do a 9-liter engine and a 13-liter engine. For MAN, Navistar. And here in Sweden for Scania, we provide the process control technology both for the 13-liter engine and the 16-liter V8. We're also active in what we call the industrial power sector. So this is off-road, things like agriculture, rail, marine, and construction. And you see big names there, the names that you know in the industry: Caterpillar, Cummins, Deutz, we do a tractor engine, Doosan in Korea, Federal Mogul here in Sweden, General Electric, we do a locomotive engine, MAN and MTU. The picture in the bottom corner is a large engine from a mining truck for MTU. Yes, the Series 2000 engine. So we have production references in each of those three sectors. Currently, our production is about 50% passenger vehicle, 40% commercial vehicle, and 10% industrial power plus other things. If we look at the production since 2009, you see this continuous growth trend. We finished last year at 2.5 million engine equivalents, and many of you will have seen the press release from just yesterday, where for the first time we reached 3 million engine equivalents. So this growth trend is continuing. In fact, January we had 2.9 million engine equivalents. In February we had this record of 3 million engine equivalents, and those were our two highest months ever. So we can see that this new level is quite sustained. Looking at the production statistics in more detail, our revenue last year was 87.7 million. That was 16% higher than our previous best year. And the operating result was 29.4 million, which was 11% higher than our best year. Let's put that into perspective. Sintercast, as I say, we're a small company. We don't actually manufacture the products. We're 22 people. So we have a revenue of approximately 4 million crowns per person, and we have a profit just better than 1.3 million per person. Our series production, as I mentioned, finished last year at 2.5 million engine equivalents. That was up 19%. And already this year, with our first 2 months of the year, we're up another 16%. And this puts us on path to continue our double-digit growth, which is always our goal, to have double-digit production growth every year. The sampling cups, so we provide a consumable that allows the foundry to sample and analyze the iron before it's produced. It's about the size of your hand. Last year we delivered 197,900 of those sampling cups. So if you do that math, it's more than 500 sampling cups per day. So our customers around the world are taking more than 500 samples per day, more than 25 per hour. Every 2 or 3 minutes, somebody is taking a Sintercast sample. While we have this presentation today, our technology will be used for the production of more than 100 engines. So we've come to the point where it satisfies everyone's definition of high volume and mainstream accepted material. This year, the board has proposed a dividend of 3.5 crowns for the ordinary dividend and 1.5 crowns for the extraordinary dividend, so a total of 5 crowns. And with the current share price at around 100, it's a 5% dividend. What's really interesting in the dividend is that we gave our first dividend in 2010, and since that time, with the current proposal, we will have transferred 155 million Swedish crowns back to the shareholders. Yeah, and this is our strategy as a company. We will reinvest in the business and the growth of the business, but the primary function is to serve as a cash funnel to transfer the excess funds back to our shareholders. So with that as an overview of the previous year and the technology, let's look forward at what's coming next. On the 16th of January, we had a press release to announce the new production of a 6.7-liter diesel engine. It's produced by Cummins, but used in Ram Super Duty pickups in the US. So this production started in the 4th quarter. It's a replacement for a current engine, so the ramp-up is very fast, and we're now almost at full volume. And this is a large part of the reason for the growth from the 2.5 million of last year toward the current 3 million. We say that the potential volume for this program is around 300,000 engine equivalents per year. I don't want to get into the technical details of the engine. I just want to show that the torque value, we have it here in Newton meters for the European audience, but the American audience presents it as 1,000 foot-pounds of torque. And this is a real landmark in the industry. So this is the first Super Duty pickup to reach 1,000 foot-pounds, and it means that you know, they have a competitive advantage in the sector. The maximum towing capacity for the vehicle was stated as 35,100 pounds. For us, that's 16 tons. Again, highest in the industry, and it's 12.5% higher than the previous generation engine, which stopped production just a few months ago. Yeah? And this is what compacted graphite iron does. With a higher strength and stiffness of the material, they can downsize the engine. You see here in the overhead that they realized a weight reduction of 27 kilos. It's approaching 10%, and CGI was a big part of that. But at the same time, they can push the engine harder. They get more performance out of the engine, more horsepower per liter, more torque, and of course, a better fuel economy and reduced CO2 emissions. Yeah, so that's what CGI brings to the design community. Also this year, on the 29th of January, we announced a new order from Scania. So many of you here in the local community will know that Scania has received environmental approval to make a foundry that will melt 90,000 tons per year of liquid iron. They've made a 1.5 billion Swedish crown investment in this new foundry. I think it tells us two things. First, the order for Sintercast, of course, that's important. But also, sometimes we hear talk about electric vehicles, and particularly electric vehicles being extended to heavy-duty trucks. And here you have a really reputable, well-known company that's investing 1.5 billion Swedish crown to make internal combustion engines. And with that type of investment, you know, they have to run that foundry for a long time to recover that investment. And so they realize that we will continue to use diesel combustion engines for a very long time. Start of production in the new foundry is 2020, so we have the order now. We will make the installation in 2020, so it's a contribution to our installation campaign for 2020. The ramp plan is to have full volume within 3 to 5 years. And what it means for Sintercast is incremental revenue of 20 million Swedish crowns per year. So currently we're at something like 90 million. It will grow between now and 2023 and 2025, but still a really big order for us and a really good step. It allows us to continue our commitment for reaching double-digit growth for the next 3 to 5 years. And here in the picture you can see the 13-liter, where our technology is used to support the production in 3 different foundries, here at the Scania foundry in Sweden, the current foundry, at a foundry in Germany, and also a foundry in Brazil. And below it, you see the 16-liter V8. Our technology is used to produce that in Germany and in Mexico. Yeah, so we've been supporting Scania since 2013, and great that we have their future business as well. So you see that we're closely linked to the diesel engine, and there's a lot of discussion, of course, about the diesel engine. So I wanted to look into that in more detail and see what our exposure really is. I mentioned previously that our current split is about 50% passenger vehicle, 40% commercial vehicle, and 10% industrial power and other. It means about 6% industrial power and 4% turbochargers and exhaust manifolds and things like that. Commercial vehicle and industrial power are diesel, and they will continue to be diesel. We don't have an exposure there, so let's just focus on the passenger vehicle side. Today, 20% of our passenger vehicle production is petrol engine, so the remaining 80% is diesel. And if you do that math, it means that about 40% of our total production is diesel engine for passenger vehicles. However, all of our production is for large vehicles. We saw the Ram Super Duty earlier. This is the Ford Super Duty. For Ram and Ford, for Super Duty applications, they are more than 80% diesel. It simply doesn't make sense to have a petrol engine of 6 or 7 liters when you need this towing demand. The fuel economy just isn't good enough. and also things like SUVs and sport utility vehicles. So indeed, diesel volume has gone down a little bit, but the volume has gone down for small vehicles, and large vehicles and luxury vehicles and SUVs, I think will continue to use diesel for quite some time. And we can put numbers to that. So this is a statistic from the Association of European Automobile Manufacturers, ACEA. You can go on their website. All of the statistics are available for free. This is a breakdown of sales in Europe in 2017. See, it was 44% diesel, 50% petrol, and a small amount of electric vehicles, whether they're conventional hybrids or plug-in hybrids. And APV is alternative power, natural gas, principally natural gas. Yeah. And fast forward to 2018, the diesel volume has decreased from 44 to 36%. And you see, all of the uptake really came from petrol engines. It's the petrols that are benefiting from this. In that volume, the reduction was, as I said, primarily with small vehicles. Our diesel production went up last year by 4%. Yeah. Where do we go from there? This is from the US. We look at the 10 best-selling vehicles in the US last year. You see that the top 3 are pickup trucks. They have been the top 3 bestsellers for the last 7 or 8 years, and for as far into the future as anyone is brave enough to forecast, they will also be the top 3 bestsellers. Interestingly, in the last 2 or 3 years, each of the Ford F-Series with our diesel, Chevy Silverado, and the Ram pickup, again with our 3-liter V6, have introduced new diesel engines. Yeah? So while there's all this talk about diesel volume going down, in fact, there are new diesel entries in the market. It is forecast that diesel penetration in the US will increase between 2018 and 2025. Also, Chevrolet with the Canyon in Colorado, the mid-size diesels. And you may have heard that Ford is reintroducing the mid-size pickup, the Ranger. All of these will have diesel engine options. So new products coming to the market. They need it. It's the only way that they can meet the fleet fuel economy requirements. Just in January, Ward's Auto, it's a magazine in North America. Well, it's a global magazine. They every year announce the 10 best engines, and our 3-liter V6 for the Ford F-150 this year won one of the 10 best engines award. And they write, diesel engines are ideally suited for big, rugged pickup trucks, and the smooth, quiet 3-liter Power-Stroke diesel V6 available in the 2018 Ford F-150 is exactly what the market needs. A light-duty diesel engine capable of remarkable fuel economy while towing heavy loads for work or pleasure. Yeah, the market needs these engines. I wanted to share another quote while we were together here in Stockholm. This is almost a year old now. It's from the Swedish Royal Academy of Sciences, from their Energy Committee. It was published last April. And what happened? In 2017 and 2018, for the first time in many years, the fleet average CO2 emissions in Europe increased. Yeah? And we have this drive toward lower CO2 emissions. The current requirement is 120 grams per kilometer, but the next target for 2020 is 95 grams per kilometer. So we have to drive down the CO2 emissions. But as we change from diesel vehicles to petrol vehicles, the CO2 emissions are actually increasing. And when the politicians and many people have seen the effect of reducing the diesel engine, we get this quote from the Swedish Royal Academy of Sciences: "It's hard to see how, without the diesel engine, we can even get close to Sweden's climate target. We consider it completely wrong to discourage the sale of diesel cars." Indeed. Indeed. So, wrapping up then on our CGI part of the presentation, our production base is strong and it's growing. It seems like this 2.93 million is the new normal for us, increasing from last year at 2.5 and the year before at 2.1. We have production references in every sector. It means petrol engines for cars, inline diesel engines, V-type diesel engines, commercial vehicles and off-road vehicles. Also, we see hybrids as an opportunity for growth for us. These engines are going to have to be small and performant, and that's exactly what CGI can do. Our 3-liter V6 that we have in Lincoln for the Aviator was announced in January that it will be available next year as a plug-in hybrid option. We have a positive installation outlook. We tend to run around 7 million crowns per year in installation revenue. Last year we had 2 orders that weren't concluded before the end of the year, so they spill over to this year and give us a really good start. I think that we'll have an above average installation year this year, and we already have the Scania order for 2020. It will be installed in June and July. The order value on that was 5 million Swedish crowns. So again, a really good head start to 2020. I think we have 2 years coming with above average installation revenue. You saw the plot earlier from 2009 to 2019. If you do that math, we have a compounded annual growth rate of 14% over those years. And as I said, I think that we can continue with double-digit growth in the core CGI market, at least for the next 3 to 5 years. Okay, so that's the CGI. Let's change gears a little bit. I mentioned that we have developed a new technology. We started that in 2015, and we're starting to get some traction with it. It's about tracking and traceability, so we measure more things in the Foundry, giving this information back to the Foundry managers so they can improve their process efficiency. The first of those technologies is called Ladle Tracker. So in the Foundry, they will melt iron and put it into a pot or a ladle, and that ladle will move from the melting furnaces through some treatment stations and eventually to the molding line where it's poured into the sand to make the castings. This is a layout of our production at the Tupi Foundry in Mexico. Just a few words about the production. Below the picture where we can't quite see, there are 3 different furnaces to prepare the iron, 2 to melt it and 1 to hold it. So the iron can start from 3 different places. It's then moved by forklift to the top corner of the picture where we have 3 different treatment stations where we take the Sintercast sample and add the alloys. From there it comes to this platform, here where they measure the temperature and take a chemistry sample. And from that platform it can move either to pouring car 1 or pouring car 2 to pour the iron into the molds. So that's all standard Foundry stuff. What makes it busy? We have 5 different ladles in this circuit, so there's always iron at each station. We have 2 different sizes of ladles because we have 2 castings. We have a 3-liter V6 and a 6.7-liter V8. So we have a big ladle for the big one and a small ladle for the small one. So 5 ladles, 2 different sizes. We have up to 20 ladles per hour of production, and we have 3 forklifts carrying them, and we have that production for more than 10 hours per day. So at the beginning of the production, we got together, Tupi as the Foundry, Ford as the end user, and Sintercast, and it was obvious to all of us that we couldn't rely on the people driving the forklift trucks to always take the iron to the right places. Sometimes it would miss a step, or they would have a confused addition. So we introduced this technology to track the ladles. Here you can see on the ladles we have these tags, these radio frequency tags, a close-up of the tag, and we can put an antenna at any position in the Foundry to measure the ladle as it passes, so we know that the ladle reports to every step in the process and is successfully treated before it moves to the next step. Here we see the ladle at the tapping furnace with its tag, and here is the antenna 2 or 3 meters away, safe from the metal splash. And what do we do with this? So if a ladle arrives at a step not having successfully completed the previous step, it will be blocked. It can't move on in the production. So if a step has been skipped, or if any of the limits for temperature or chemistry or weight or anything else are outside, it will be stopped so that only good metal is poured. It's a really great tool for improving the process. So if they tap 1,000 ladles from the furnaces, they would also like to pour 1,000, but some ladles always fall out of the process. And with this technology, we can tell them where the ladles fall out, and why they fall out, and give them the information that they need to go and eliminate the bottleneck and improve their process efficiency. There's also a time limit for every ladle. In this case, we have a 6-minute and 30-second time limit. So when the ladle comes to the end of that time, the pouring car automatically stops to make sure that we don't pour old iron. The data is available to the Foundry. It's automatically streamed to their quality system. The Foundry manager can look at it on his computer or his mobile telephone. And it allows us to set targets. So for example, if 5% of the ladles are being timed out for a given shift, we can set a new target for them of 4%, and we can measure that and give feedback to the operators. So it's a really exciting tool, and we look forward to introducing it in the market. We already have 3 customers, and we'll get more. Thank you.
Yes, I'm afraid we have to to cut here, but just one fast question. My first question was initially meant to be, when will you reach your milestone of 3 million engine equivalents? Yes, yesterday. So now we'll clear that. And of course, this huge Scania contract will increase your sales 20 million annually when it's up and running in full production. Just how important is this contract for you and the future of CGI production?
Well, it's a very big step for Sintercast. It will become one of our bigger customers. If we're at 90 million now, you know, maybe by then we'll be well over 100 million. So think of it as a kind of a 20% increase. I think, again, it reinforces the need for diesel engines in the future. They wouldn't have made that investment if they thought everything was going to be electric in 2025. So for Sintercast, it's a big order, and for the market, it's a strong message.
And just one final. If we go to the market, your market share, you're market leading, and what is your share, do you think? And what is the underlying growth in the market of CGI?
I would say that the Sintercast technology is used for about 60%, 70% of the world's high-quality CGI production. There are also some simple things that are produced, furnace bodies and things like that. We're not in that business. But if you think of the demanding application like block and head, we're probably about 2/3. Yeah. And the overall growth, you know, the bigger the pie, the bigger the Sintercast piece. We will have double-digit growth. The CGI market will follow that.
Okay, thank you so much, Steve, for coming here.
Thank you.
Steve.